Welcome back to Math Heads 101. Alright. Today we're going to be discussing derivatives. So, derivative is a fancy word for slope. If I have a function, the derivative at this point is the slope at that point. The derivative at this point is the slope at that point. The derivative at this point is the slope at that point. So, you might say, okay, why would you care? That's the slope. Well, sometimes it's important. So I'm going to give you a simple example on why the slope might matter so you don't feel like you're learning this for nothing. And then I'm going to teach you how to calculate the slope at any point. So let's say this is your function of x and this is your x-axis. Okay, now let x be, because a function, you give it an input and I'll give you an output. So this function that I'm going to graph is a profit. And x is going to be a number of donuts. And you're running a donut business. No, x is the price of the donuts. Yes, I'm kind of making this problem up on the spot. X is the price of the donuts. So if you have your price of your donuts is 0, and we're going to assume you get the donuts for free, so you can't lose any money. So you're getting the donuts for free, and if you sell them for 0, everyone's going to want to buy donuts because they're free donuts, but you're not making any money. So there. Now, if you sell these donuts for infinity number of dollars, one donut, well, give me infinity dollars. Okay, nobody's going to buy that. Nobody can buy that. So it's going to go down and go towards the 0. Okay? The more the donuts cost, the less people are willing to buy or can buy, or both. Okay, so it's going to look something like that. Okay? Except it's going to look nice. Okay, so at some point you're going to make a maximum, and then people are going to say, screw these donuts, they cost too much, and less people are going to buy. And more, okay. So you have more and more profit up to some point, and then less and less profit. So let's see, where you maximize your profit, the slope is 0. And then everywhere else, the slope is, well, here the slope is positive, and here the slope is negative. So the cool thing about 0 is you have to cross from positives to negative to get there. But that doesn't mean that you're always going to. Like if I have this, it's touching 0, but it's positive and it's positive before. But here the slope is positive before and negative after. So 0 there. So often if you want to maximize or minimize things, set derivative equals 0. But I just wasted 3 minutes talking about nothing. Okay. So what is the slope? The slope is the change in the value of the function over the change of the input. Or you might know that as delta y over delta x. Okay. So the notation for derivative is dy over dx. So what's the difference? Delta's finite. Well, they're both finite. D is a very small delta. It's like the smallest delta in the world. Okay, so let's take a look. Okay. So the derivative, okay, I'm going to spell this wrong, so I'm not even going to try. I'll just say slope, because I know how to spell that. The slope is equal to, now we know about limits, so we can use them. The limit as h goes to 0, and then you have, delta means your initial plus your final plus minus your initial. So f of x plus h minus f of x. Then you have x plus h minus x. And you might be like, hey, where did this crazy formula come up? I don't even think you could see the board. Whatever. Okay. I'm going to use black. So, look. Here's your graph. Yeah, there's a graph. You want the slope right here. Okay, well, you're going to take 2 points. We'll call that x. We'll call that x plus h. And this guy is f of x. And that guy right there is f of x plus h. So this is the value of your function at some random x. This is the value of the function at some random x plus h. And this is x and this is x plus h. And this distance right there is h. Okay. So it's different for different functions, but any function you can add an h to it. So this is the general way to write it, but then if you have like a specific function, you can calculate the derivative for that. So that is what a derivative is. So let's calculate one. Let's say f of x equals 2x. So we're going to say df of x over dx, which denotes that we're going to take the derivative, is equal to the limit as h goes to 0 of 2 times x plus h minus 2 times x all over x plus h minus x. Okay, so now you're saying we have a positive x and a negative x, those cancel out. So we just have an h on the bottom. Okay. And then we have a 2x plus h minus a 2x. 2 times, so we can factor out the 2. So it's equal to 2 times, we're going to factor out 2x. 2x times h over h. So that cancels out. And the derivative, fuck you guys.